For months, Voyager 1, a spacecraft older than the Internet itself, had gone completely silent. 15 billion miles from Earth, no signal, no data, just emptiness. A silence so deep, so absolute, it felt like the universe itself had drawn a curtain. Scientists feared the worst. Had our furthest explorer finally died in the dark? And then, just as hope was fading, a whisper returned. But it wasn't a routine update. It wasn't a reboot or a system check. What Voyager 1 sent back shattered our most comforting illusion, that the space beyond our sun was just an empty void. Because what Voyager found out there wasn't nothing. It was structure, motion, and boundaries. It had reached the other side, and what it found there defied every expectation. Keep watching. Because the truth Voyager is revealing about the interstellar medium is more astonishing, and more unsettling, than fiction ever dared to suggest. When Voyager 1 crossed the heliopause in 2012, it became the first human-made object to truly leave the sun's protective bubble. Most believed it would drift into silence, fading into a cold, empty stillness. But in April 2024, after months of scrambled signals, Voyager came back to life. And what it began transmitting shook the foundations of astrophysics. Out there beyond the heliopause, space isn't silent. It's humming, a low, rhythmic vibration filling the void, like the pulse of something alive. Voyager's plasma wave detector picked up this steady background tone, a cosmic heartbeat echoing through the interstellar medium. But it wasn't just the hum. The probe also detected sudden spikes in density, bursts of pressure like shockwaves, remnants of ancient supernovas long extinct. It was as if Voyager was sailing through layers of memory, drifting through regions shaped by stellar deaths that happened thousands, maybe millions, of years ago. Interstellar space isn't an empty corridor. It's a vast ocean of invisible tides and currents. And Voyager is our tiny sailboat, moving through a storm we never even knew existed. As it pushed deeper, its instruments painted a picture no telescope ever could. A three-dimensional landscape hidden in darkness. Its magnetometer detected a sharp twist, a violent clash between the galactic and solar magnetic fields, like two tectonic plates grinding together. This wasn't random. It was patterned. The turbulence hinted that the galaxy itself might have a magnetic skeleton, invisible filaments of force shaping how matter flows and where it gathers. Some regions deflect cosmic rays. Others funnel them like rivers of radiation. Voyager found itself crossing one such current, a spike in high-energy particles hurled across the galaxy by black holes and dying stars. These weren't gentle transitions. They were abrupt, like stepping off a cliff into another world. We once thought the sun's influence faded softly into space. Voyager proved it ends sharply, like the edge of a cosmic reef. By late 2023, it seemed Voyager's mission was over. Its signals were scrambled, its memory corrupted. But NASA's engineers didn't surrender. From 15 billion miles away, they performed the most distant repair in history, rerouting Voyager's code into backup memory from the 1970s. Commands took 22 hours to travel one way. It was like performing brain surgery through time. And it worked. Voyager reawakened, first its engineering data, then its magnetometer, then the plasma and cosmic ray sensors. One by one, the instruments came back to life. And with each reboot, the spacecraft gave us something no telescope, no AI, no simulation ever could: first-hand readings from the darkness between stars. Voyager wasn't just restored. It was reborn. And with it, our window into the deepest truths of the galaxy opened once again. What Voyager sends now isn't mere data. It's a blueprint, a living map of interstellar space. Scientists are using its readings to sketch the first ever galactic GPS, not for planets but for radiation zones, magnetic boundaries, and invisible fog banks. Voyager has already passed through at least 2 interstellar clouds, each with its own density, temperature, and magnetic structure, like continents separated by unseen borders. One day, these maps may guide human explorers through safe corridors, using natural magnetic shielding to dodge cosmic radiation. But perhaps most astonishing, these structures may reveal how stars are born. The pressure zones Voyager detects could be the same places where new suns ignite. Voyager isn't just an explorer. It's a cartographer, tracing the anatomy of our galaxy. We used to imagine interstellar space as still and empty. Now we know it's dynamic, more like an atmosphere than a vacuum, complete with pressure zones, currents, and storms. Voyager is recording interstellar weather, sudden shifts in temperature, density, and radiation, as if it's flying through invisible clouds. Each region has its own climate. Some zones hum with low-frequency energy. Others crackle with the residue of ancient explosions. It's like discovering ocean currents in what we thought was desert. Space, it turns out, isn't still. It's alive. Voyager is now moving through the outskirts of something called the local bubble, a vast cavity in space carved by supernovas millions of years ago. Its edges are jagged, magnetic, distorted, scars of ancient stellar violence. And Voyager's instruments are now mapping those scars, step by step. Within these regions, the probe may be hearing the echoes of dead stars, literal shockwaves and charged particles still drifting across the galaxy. Voyager is sailing through a graveyard of suns, decoding the story of their deaths written in plasma and dust. But perhaps the eeriest revelation of all, there is no silence out there. Voyager's sensors keep detecting faint, constant vibrations, a low cosmic hum that never fades. It shifts slightly as the probe moves, as if it's entering new zones of resonance. It's not radio noise. Not background radiation. It's something else, perhaps the resonance of the galaxy itself, the background heartbeat of creation. Some scientists think it's magnetic turbulence. Others wonder if it's something we don't yet have the words to describe. Whatever it is, Voyager isn't just hearing it. It's moving through it. And for the first time in history, we are listening with it. Voyager's discoveries are transforming how we imagine the Milky Way, not as a flat map of stars, but as a living terrain made of energy and force. Every change in particle density, every twist in the magnetic field, every ripple in cosmic rays, these are landmarks in a new kind of cosmic geography. Voyager is drawing the first topographical map of the interstellar medium. Mountains of radiation. Valleys of low pressure. Ridges carved by supernovas. The unseen bones of the galaxy. One day, this data may show us pathways through the stars, corridors of safety, routes of birth and death, zones of peace in a violent universe. Voyager 1 wasn't built to find life or conquer space. It was built to listen, to whisper back across the dark. A machine, older than most of humanity's digital memory, still carrying our voice, our curiosity, and our hope. What it's revealing isn't fantasy. It's not aliens or wormholes. It's something far more profound, the realization that we live inside a fragile oasis, surrounded by a storm of forces we barely comprehend. Every hum Voyager hears, every magnetic ripple it maps, every anomaly it records, brings us closer to understanding not just where we are, but what the universe truly is. So the next time you look up at the stars, remember, 15 billion miles away, a golden-plated traveler is still out there. Still drifting. Still listening. Still sending whispers home. And maybe, just maybe, it's reminding us that the greatest frontier was never out there. It was always our need to understand. If you've made it this far, you're one of the few who truly listens when the universe whispers. So tell us, what do you think Voyager will find next? Beyond the maps. Beyond the models. Beyond everything we thought we knew. Subscribe to our channel and thanks for watching.